this thing is called Amnota, and it seems pretty, you know, but this is the message here, and although it's written in English, it's kind of hard to read. Due to work in progress, taxiway P sub closed between F and R, taxiway R closed between A and B, and something else. So you have to really know what's written there. But in our case, that wasn't a problem, because what we need actually is involved here, and these are coordinates. Because our users need to connect that message to a point on a map, and getting those coordinates to a computer was major manual work. And in this example, we can have only one point, this one. But imagine you have 5 points, or 10, or 100. And that's the book. As you can see, it has old company logo, because we didn't update that yet. And you can drop files, text files in that area, and click convert, and it will detect lines and all the points will display on the map. And it's available as a website. So let's go to the design part. You cannot see in detail here that that's perfect, because the details are not important. You introduce bugs by selecting runtime environment, and in our case, we want to work in what's the most available to us, and that was Windows Virtual Machine. And if you think that's bad, yes, it's bad. So if you run a front-end or back-end process on a virtual machine, you usually start by running from the command, and it's available in your network. But virtual machines run Windows operating, and that system has to be updated at some point. So when you update that system, your virtual machine has to be started, and your command line process is gone. Your application doesn't work, and you can back, but the app doesn't work. So you can avoid that by creating a scheduled task, and you know, just create a simple bat file and run it on a start, and don't stop. Run it reverse. When update comes, your virtual machine reboots, and the process starts, and app is available on the network. Another way to introduce bugs to your application is by running not proper version of your code. And the question is, where do you store your code? And everyone will answer, store our code in a repository. Yeah, that's perfect, but is that code being run actually? And I would like to tell a story here about me who does introduce a bug application. So I fixed one feature, a functional feature, and vacation, and didn't do any commits, push the repository, and I was so happy that I'm going on vacation that I forgot. And of course, I copied and pasted the file of virtual machine, because you can do this when you are using virtual machines. That's why they are bad. And after the validation, I bug fix files and copied and pasted, and the bug reappeared. So it's important to run one version of your code preferably on the repository .basis. And we also have to decide where we have to stop worrying about running program. So this slide is from about and we as testers usually stop our worrying about how things work underneath at the operating system level. But there is a lot of going on between. So from operating system, we go virtual machine, assembly language, with some processes in to assembler, machine language, hardware, chips, logic, physics. So there is something on, and it doesn't matter if you run virtual machine or Docker, container, because it will end up at physics level still, but you have to trust that something works good. So the easier approach here is to define the time frames that the tool is used. And in our case, it was we used that in Poland, Germany, and United States. So we had like 8 hours to deploy that. So that's plenty of time. Just do it at night, and you don't have to care about continuous deployment in that case. But there are questions like, how fast can you deploy? In our case, it was like 5 minutes or something like that. But in other cases, it could be long. It could be longer than your time frames. But then, well, what stops you? And very often is testing. And testing can be a very long process, especially when it's done incorrectly. But if you reduce the amount of tests to the most important, you can deploy with that approach. So after your application is running on your runtime environment, you would like to monitor it somehow. So how does it use computer resources? Like, for example, this application creates a file, zips it, and sends it back to the user. We have to zip our shape files, they are called shape files, and we do that because it was easier for us to zip 7 files, because a shape file is a 7-file collection, and send it back to the user. It breaks your idea about how file systems should work, and they are really hard to operate with, but they are industry standard, so we have to use them. And if our application runs out of disk space, it crashes. So we have to monitor that somehow. And we did something actually that cleans after everyday after everyday work at night the disk space, so it will never crash. We feel safe here. And for the other part of, maybe you want to know if your application actually works at that time, and there are tools for that. and probably you would like to build your own tool because you only want to monitor very simple thing. And maybe that's a good idea, maybe not, but it's for sure the fun part of creating such small tool. And I would also like to add that you should define what you need to monitor and monitor only that, because you can easily fall out into information noise, like if information that are reported to you are useless to you, you won't care about that. And the last thing about introducing bugs is do it with junior developers, and I will tell you why. Because nowadays a lot of people would like to learn coding, and learning coding is hard, you know. And if you use commercial solutions like programming schools, etc., it might be expensive. As I learned programming, I did that by trial and error, and it was like mostly error all the time. But for me, that's the only way. So if you ask somebody who works in your company who might be not that skilled in programming and is willing to learn, it will be better for you because you will find another person who could maintain that later. Because if you write another perfect tool with perfect code and present that to your boss, the boss will say, yeah, okay, now you maintain that. And if you have friends with you, it's easier. So I highly recommend that. We created that tool with 6 junior developers and 2 senior ones. But we mostly just monitor their work, and it's fine, and it's working, and we found all the bugs and removed them. So after one tool is finished, and somebody learned to program based on that, and the risk that something will go wrong with that is very low, you can get the new idea, maybe ask somebody else, what's your problem, you know, what are you doing manually, and what we could help you with. And if that person is willing to learn programming, you will have another person willing to maintain your program, and that's important person treated like a friend. So the key takeaways from this presentation would be you don't have to build the most perfect tool, the most advanced tool to achieve your goal. And if your goal is reducing manual work by very little amount, that's the simpler the tool, the better. And please check what you need before implementing it, because maybe you will spend time on implementing something that you don't actually need, and that's wasted time actually. And for the final statement of that presentation is on this picture. And in Polish it sounds a little bit different. We kind of create a cannon to kill a mosquito, and if you can do that for me, please don't create that cannons. Create simple tools. Thank you.